So see here, at first you have to know when matrix multiplication is exists. Okay. So what it is given? Let A and B be any two non-zero matrix. Okay, A and B be any two non-zero matrix. Then AB exists. Okay, then AB exists when, that means we can multiply two matrix if number of columns of A equal to number of rows of B. Okay, number of columns of A is equal to number of rows of B. That means matrix multiplication exists if the number of columns of the first matrix is equal to the number of rows of the second matrix. Okay, if the number of column of the first matrix is equal to the number of rows of the second matrix, then only what happened? Matrix multiplication exists. Clear? Suppose I have given, suppose A be a matrix of order m by n and B be a matrix of order n by l. Okay, A be a matrix of order m by n and B be a matrix of order n by l. Then AB be a matrix of order what? M by l. See here, these two are, what is the order of A? This is m by n. And what is the order of B? This is n by l. This both n will be cancel. Now what is the order of AB? It is m by l. Okay, so it is m by l. See here, I give one example. What it is given? See, A is a matrix. What is the order of the matrix? It is 3 by 2. Again, another matrix B is given. So what is the order of the matrix? It is 2 by 3. Clear? Then what is AB? So at first you have to define what is the order of the matrix AB. Clear? So this 3 by 2, it is 2 by 3. So this 2 will be cancelled. So order of the matrix will be, it is 3 by 3. Clear? It is 3 by 3. 3 by 3 means how many rows are there? 3 rows are there, row 1, row 2 and row 3. And how many columns are there? There is also 3 columns, column 1, column 2 and column 3. Clear? So this will be, see, row 1, column 1. First element will be row 1, column 1. Second one will be row 1, column 2. Third one will be row 1, column 3. Next, for second one, this is row 2, column 1. We have to proceed in this way. That means row 2, column 2, row 2, column 3. Again, it is row 3, column 1, row 3, column 2, and row 3, column 3. Clear? So we have to multiply this. See, what is the first one? Row 1, column 1. See how we can multiply this one. We have to take the rows from the first matrix. Okay, we have to take the rows from the first matrix and column from the second matrix. See here, row 1, column 1 means what we have done. We take the first row of A, 2, 1. See, we take 2, 1, and column 1, we take the first column of, B. This is 1 minus 1. Now what we have to do? We have to multiply the corresponding element. This is 2 into 1. 2 into 1 plus, next what is the corresponding element? 1 into minus 1. So what you got? 2 into 1, 2. 2 minus 1, 1. Okay. So in this way, we can multiply this whole elements and find AB. Now tell me, is there any doubt in matrix multiplication? Tell me if is there any doubt, all of you? Clear to all of you? Is it or not?
Sir, no doubt, sir.
What?
Yes, sir, clear.
Okay. You got this in your rates. Now, I think this portion also, you know, properties of matrix multiplication. So first property is what? Matrix multiplication is not commutative. That means it is not always commutative. That means AB, sorry, this will be not equal to BA. AB not equal to BA. In some may be equal, in sometimes may be equal to BA, but it is not always equal. Okay. So you write it properly, AB not equal to BA. See, I give one example, A and B. So here, what is the order of A? It is 2 by 2. And what is the order of B? It is what? 2 by 2 by, sorry, 3 by 2. So in this case, what happened? When matrix multiplication exists, if the number of columns of the first matrix is equal to the number of rows of the second matrix. Here number of column is 2, number of row is 3. So this is AB does not exist and BA exists. Okay. Now matrix multiplication is associative. Okay, matrix multiplication is associative. That means A into B into C equal to A into B into C. Clear? So next one is A into I equal to I into A equal to. That means if you multiply any matrix with the identity matrix, the result will be always the same matrix. Okay, always remember these things. If you multiply any matrix with the identity matrix, the result will be always the same matrix. Here A into I or I into A, it will be always clear. Now it is transposition of matrix. I think all of you know what is matrix transpose. Okay, so it is nothing but, see here, the matrix obtained by interchanging rows and columns. The matrix obtained by interchanging rows and columns is called transpose of the matrix. It is denoted by A dash or AT. This one example is given. A is a matrix. So 1, 2, minus 1, 0, 3, 1. So what is the order of the matrix? It is what? How many rows? 2 rows, 3 columns. So 2 by 3. So when you transpose it, first row become here first column. See here, first row is 1, 2, minus 1. And it will become first column, 1, 2, minus 1. Second row is 0, 3, 1. So this second row becomes second column, 0, 3, 1. So simply what we have done here, we interchange rows to columns. Okay, we interchange rows to columns. Now see properties of transpose of matrix. So A dash dash equal to A. That means if you transpose 2 times, then the result will be again the same matrix. Clear? Again, A plus B whole dash or A minus B whole dash equal to what? A dash plus minus B dash. Clear? A dash plus minus B dash. Now, AB whole dash equal to what? B dash into A dash. You have to interchange this. A into B whole dash equal to B dash into A dash. Clear? Now K into A whole dash equal to K into A. Here K is nothing but it is simply a constant. Suppose K equal to 2 also, K equal to 3 also, in like that. Okay, or something, any constant. It is simply a constant. Now, is it clear what is transpose of a matrix? All of you?
Yes, sir.
It is clear? Now it is.
multiplication addition
Yes, sir.
one minute.
1 minute. ओए प्लीज सब अपना माइक ऑफ करो तो पहले सब अपना माइक ऑफ करो यार.
What happened?
Okay.
So everyone is talking in the mics in the group. So everyone is talking. Everyone's mic is on and some are talking.
Okay. All of you mute
Sir,
yourself.
everyone
If
off
I
your mics.
ask any question, then you have to unmute it. Okay. So at first, all of you mute this mic, and if I ask anything, then unmute it and give the answer. Clear? Now see here, symmetric and skew symmetric matrix. Okay, so first one is what? A square matrix is called symmetric matrix if A dash is equal to A. That means what? After transposing the matrix, if we got the same matrix, then the matrix is called what? Symmetric matrix. So here this is the matrix A. If we transpose this matrix, see here what you got. First row become first column. First row is 3 minus 1, 2. It will become first column, 3 minus 1, 2. Second row is minus 1, 5, minus 4. It will become second column, 1, minus 1, 5, minus 4. Again, third row is what? 2, minus 4, 1. And it will become third column, 2, minus 4, 1. Clear? So now you see here, after transposing, these two matrices are same. So that means from here, what you got? A dash equal to A. Clear? A dash equal to A. So this A is what? Symmetric. Simply you listen one thing properly, how we can, by seeing the matrix, we can directly say that the matrix is symmetric or skew symmetric. How we can say this one? See here. At first, you have to write these diagonal elements. Okay, to write a symmetric matrix, always remember at first you have to write these diagonal elements. You can put any elements, no problem. So after that you have to enter these elements. If you put here minus 1, then it will be also minus 1. If you put here 2, then it will be also 2. If you put here minus 4, it will be again minus 4. Now, if you do this one, then you will directly get one what? Symmetric matrix. Okay, I think it is clear. Now come to skew symmetric matrix. Okay, come to skew symmetric matrix. So a square matrix is called skew symmetric if A dash is equal to minus A. If A dash is equal to minus A, then the matrix is called what? Skew symmetric matrix. Now I give one example here. After transposing this one, you got this one. And if you take common minus sign, you will get this one. Okay. Now see, similar way, by seeing the matrix, you can directly say that it is symmetric or skew symmetric. See how we can know this one. At first, you have to write these diagonal elements. And always remember, for skew symmetric matrix, the diagonal elements are always equal to 0. For skew symmetric matrix, diagonal elements are always equal to 0. Okay. After that, you have to write those elements, and always remember the numerical value of these elements should always same, but this sign is opposite. That means if you put here 4, here you have to put minus 4. If you put here 5, here we have to put minus 5. If you put here minus 8, then you have to put here 8. Clear? So again, I tell you, at first you have to write these diagonal elements, and for skew symmetric matrix, diagonal elements are always equal to 0. Okay, and you have to, after that you have to write those elements. The numerical values of these elements will always same, but the sign is different. Okay, so after transposing first row 0, minus 4, minus 5, it will become first column 0, minus 4, minus 5. Again, second row is what? 4, 0, 8. It will become second column 4, 0, 8. Third row is 5, minus 8, 0. It will become third column 5, minus 8, 0. After that, you take common minus sign. So when you take common minus sign, so it will be 0. It will becomes minus 4 because minus minus it will be plus 4. So when you take common minus sign, you will get this matrix is equal to A. So that's why you got A dash is equal to A. Clear? So this is called skew symmetric matrix. Now it is come Hermitian and skew Hermitian matrix. Okay, Hermitian and skew Hermitian matrix. So A square matrix, A is called Hermitian if A theta equal to A. A square matrix, A is called Hermitian if A theta is equal to A. So A theta means what? A theta means what? A bar dash. Okay, A theta means A bar dash. It is called conjugate. You know this one. You got it in your. It says conjugate of an element. See here, I give one example. If x equal to 2 plus 3i, then x bar is equal to what? 2 minus 3i. That means it is nothing but what happened? The sign of the imaginary part is changed. Okay, the sign of the imaginary portion is changed. Clear? Now see here how we can write a Hermitian matrix. It is very important. So at first see here, at first we have to write these diagonal elements 2, 3, 1, and always remember for Hermitian matrix the diagonal elements are always real numbers. Okay, for Hermitian matrix the diagonal elements are always real numbers. After that, see here, you have to put those numbers, and these are always conjugate of each other. We put here 2 minus I, then it will be 2 plus I. Conjugate means the sign of the imaginary part is different. If you put here 4, then it will be also 4. If you put only the real numbers, then the sign will also same. Okay, but if you put some imaginary number, then the sign of the imaginary number will be changed. See here, if you put minus I, then it will be I. Okay, so now we take the conjugate of A bar, that means. So 2 is 2. Conjugate of 2 plus I, it will be 2 minus I. Conjugate of 4 is 4, remains same. Conjugate of 2 minus I is 2 plus I. Now after that it is 3. After that it is I. Conjugate of I is what? Minus I. Okay. Conjugate of I is minus I. Again 4 will remain as 4. Conjugate of minus I is become I. And last one is what? 1. Okay. Now see. Now if we transpose this one, first row is what? 2 minus I, 4, it will become first column. Second row become second column. Again third row become third column. Now you compare this one with A. A bar holders compare with A. See, both matrix are same. That means what you got? A bar holders equal to A. Okay. So this matrix is called what? Hermitian matrix. Now you tell me, is it clear or not? Someone unmute yourself and tell me, is it clear?
Yes, sir. Clear.
Okay, clear, na? Okay, so it is important what is Hermitian matrix. You have to know it is A theta equal to A, where A theta means A bar whole dash. So I think you can also understand how we can write a Hermitian matrix. Diagonal elements are always real numbers. After that, you have to write these elements conjugate of each other. This is called Hermitian matrix. Now it is skew Hermitian matrix. Okay, skew Hermitian matrix. Same as in case of skew symmetric. In case of skew symmetric, it is what? A dash equal to minus A. So what is skew Hermitian? A theta equal to minus A. where A theta means what? A bar whole dash. Okay, A bar whole dash equal to what? Minus A. See here now. And one thing you have to remember, in case of skew symmetric matrix, the diagonal elements are always either equal to 0 or it is an imaginary number. Okay, so diagonal elements are either 0 or it is an imaginary number or purely imaginary. See here, we got trici, which is purely imaginary. This is we got 0 and this is minus I. That means what we have done, we consider diagonal elements as either purely imaginary number or it is 0. Okay, now see, listen it very carefully. After that, how you have to write this number? In this number, the sign of the imaginary part remains same, but the sign of the real part will be changed. See here, this is minus I, it is also minus I, but real part is what? 4. Since we put here minus 4, it will be plus. Again, come here. If it is 2 plus I, it is minus 2 plus I. That means sign of the imaginary part is remains same. It is plus I. It is also plus I. But the sign of the real part is changed. Here it is minus 2. Here it is 2. Okay. Now since since you put here on the imaginary, then it is remains same. I. Clear? So now at first we have to take the conjugate of this. So 3I bar equal to minus 3I. This, if we take whole bar, that means sign of the imaginary part will change. So it is minus 4 plus I. So here it is, if you take the bar minus 2 plus I, it will be minus 2 minus I. Again, this 4 minus I, it will be 4 plus I. 0 will be 0. I bar equal to minus I. 2 plus I bar equal to 2 minus I. Again, I bar equal to minus I. Minus I bar equal to plus I. Okay, minus I bar equal to plus I. Now you have to transpose this matrix. You have to transpose this A bar. Okay, then first row become first column. First row is what? Minus 3I, minus 4 plus I, minus 2 minus I. So it will become first column. Second row become second column. Third row become third column. Okay. Now from here, if you take common minus sign, from here, if you take common minus sign, then the matrix you got is equal to the given matrix A. Okay, then the matrix you got is equal to the given matrix A. That means from here what you got? A theta equal to minus A. So this type of matrix is called what? Skew Hermitian matrix. Is it clear? So if I ask you what is the diagonal elements of a skew Hermitian matrix are what? Tell me, anyone? Yeah, tell me, the diagonal elements of a skew Hermitian matrix is what?
Any imaginary element or 0.
Yeah, it is what? Either an imaginary element or it is
Or
0.
0.
Good. Okay, but you have to know one thing. You cannot say that any square matrix is always a skew Hermitian matrix or skew Hermitian matrix or symmetric matrix or skew symmetric matrix. You cannot say it. It may be symmetric or may not be, no problem. But these are the conditions when we can identify a square matrix as a symmetric matrix or skew symmetric matrix, as a Hermitian matrix or skew Hermitian matrix. Okay, now come to the next point. Idempotent matrix. Idempotent matrix. So what is called an idempotent matrix? So a square matrix is called idempotent matrix if a square is equal to A. Okay. So if a square is equal to A, then the matrix is called what? Idempotent matrix. Here I give one example. A is given. We find out A square. A square means A into A. In the first row, I explain it. See here, 2 into 2, 4, plus 2 minus 4. So if you add this one, it will be 2 minus 2 minus 4, and you can multiply yourself, you will get the same. Okay, after multiplying A into A, you will get the same matrix. Clear? So this type of matrix, these are very important for get view. Okay. So you remember these things. What is an idempotent matrix? If A square equal to A, then the matrix is called idempotent matrix. Now it is actually, remember, it is nilpotent matrix. Nilpotent matrix. Okay. So what is a nilpotent matrix? A square matrix is called a nilpotent matrix if A to the power k equal to 0 for some positive integer k. Okay, if A to the power k equal to 0, then the matrix is called what? Nilpotent matrix, where k is some positive integer. This one example, A is given, we got A square equal to 0, then matrix A is called nilpotent. Okay, now listen, listen, you have to remember. So here 2 is the least positive integer for which you got A square equal to 0. Therefore, its index is equal to 2. That means suppose you got a matrix A where you got A to the power 4 is also equal to 0 and A to the power suppose 7 is also equal to 0. Listen, you got A to the power 4 is also equal to 0. A to the power 7 is also equal to 0. But which is the smaller one? 4 or 7? 4 is smaller than 7. That means at first you got A to the power 4 equal to 0. So your index will be 4. That means, listen it carefully, the least positive integer for which A to the power k is equal to 0, that is called the index of the matrix. Clear? That means if you got A to the power k equal to 0 for some k, then it is called what? Then it is called what? Nilpotent matrix. So I give one example here. This A, you try yourself. You try to solve yourself. At first find out A square. If it is not equal to 0, then find out A cube. And proceeding in this way, you will get the index of the matrix. That means once you got, suppose you got A cube equal to 0, then index will be 3. If you got A to the power 4 equal to 0, then index will be 4. Okay. So in this way, now it is involuntary matrix. Okay, involuntary matrix. So a square matrix is called involuntary matrix if A square is equal to I. Okay, if A square is equal to I, then the matrix is called involuntary matrix. So I give one example here. A square, A is given, A square, we got this one. So here one condition is given, A square plus BC equal to 1. So by using this, you got A square equal to I. Okay, so this type of matrix is called involuntary matrix. Okay, so time is sorting out here, only 3 minutes left. So if is there any doubt, you can ask me. So that's all for today. I will give this PDF in your WhatsApp, in our WhatsApp group. Is there any doubt? You can unmute yourself and now you can ask me if is there any doubt. It is clear, everyone. If is there any doubt? Okay, no doubt. Okay, then that's all for today. Okay, so next class, in the next class, I will start how we can find out the inverse of a matrix by using elementary row and column operation. Okay, so these are the basic things you have to know. What is nilpotent matrix, what is involuntary matrix, like that. So any doubt? Okay, then that's all for today. Your roll number is, please give your roll number in the group. Okay, please give your roll number and name in the group. Okay, then that's all.